Welcome to the world of physics. Hi everyone, welcome to an exciting and knowledgeable physics class. Today we are going to discuss something very important in science, which is magnitude and units. Have you ever wondered how we can measure things like length, time, or even temperature? What measurement tools and units do we use? In this video, we will explore it. Are you ready? Let's dive into the world of magnitude and units. The first material we will discuss is physical quantity. Do you know what is physical quantities? The definition of physical quantities is everything that in terms related to physics measurement that can be measured and can be expressed with numbers. Physical quantities are divided into two main types, namely the first one is principal quantity and the second one is derivative quantity. The definition of principal quantity is a quantity whose units are defined. And then the definition of derivative quantity is a quantity whose units is derived from the units of the mean quantity or principal quantity. There are examples of principal quantity. The first is length. Length has the SI unit meter, and the dimension is capital letter of L. The second is mass. Mass has the SI unit, that is kilogram. The dimension of mass is capital letter of M. And then the third is electric current strength, has a SI unit ampere, and the dimension of it is I capital letter. And the fourth is time. Time as the SI unit second. The dimension of time is capital letter of T. The fifth is temperature. Temperature has the SI unit, that is Kelvin, and the dimension of temperature is theta. And the sixth is amount of substance. Amount of substance has a SI unit, mole. The dimension of amount of substance is capital letter of N. The seventh or the last one is light intensity. Light intensity has SI unit as candleland or city. Dimension of light intensity is capital letter of J.
Well, next up is measurement, because measurement is part of quantities and units. What is measurement anyway? Measurement is the activity of finding value of an object by comparing the object with a measuring instrument with a specified unit. The first example of a measuring instrument is meter or ruler. Meter is a measuring tool for length which is included in the basic quantities. Meter is used to measure the length, width, and thickness of an object. Then the second is a stopwatch. A stopwatch is a measuring tool for time which is a quantity. Stopwatch is used to measure the time taken to perform activities that have accuracy to the second level. Next, the third is the balance sheet or neraca in bahasa. Neraca is a measuring tool for mass which is a basic quantity. A balance sheet is used to measure the mass of objects with an accuracy of 0.01 grams. Fourth, there is the lux meter. Lux meter is a measuring instrument for time intensity which is included in the basic quantities. Lux meter is used to measuring the intensity of light, the main functions of a lux meter. The next is fifth. Thermometer is a temperature measuring instrument which is a basic quantity. A thermometer is used to measure temperature or a device used to express the degree of cold and heat of an object. Six is ammeter. Analog ammeter is an electrical measuring instrument which is included in the basic quantity. Ammeter is used to measure the value of electric current flowing in an electrical circuit. The last one is the TDS meter. TDS meter is a tool for measuring substances which are included in a basic quantity. TDS meter is used to measure the amount of dissolved particles or measure levels or measure quality in drinking water. It is the seven principal quantities, each of which represents with one-dimensional index and one international standard unit defined for each of these quantities.
Derivative
Derived
measures.
quantities, well, as we have discussed earlier, derived quantities are quantities whose units are derived from the principal quantities. Okay, first we will derive from the main quantity of length. For the unit of area is the meter multiplied by the meter, so that the unit is the meter square. While the dimensions for the area are the dimensions of the length L and the dimensions of the width L as well, so that dimensions are L square. Okay, next, volume. The unit of volume is the unit of length meters, the unit of width meters, and the unit of height is also meters. The result is cubic meters. Well, while the dimensions of the volume are the dimensions of the length in L, the dimensions of the width are also L, and the dimensions of the height are also L, so the dimensions of the volume are cubic L. Well, from one main quantity of length, we can get two derived quantities, namely area and volume. Well, next, what if we want to derive from the quantities of length and volume? Next, what if we want to derive from the length and mass quantities? Then the derived quantity that we get is density. Well, if you remember, the equation for density is represented by the letter rho. Density for our density is equal to mass divided by volume, so that the unit is the unit of density, the unit of rho is the unit of mass kilogram, and the unit of volume cubic meters kilograms per cubic meter. Our friends can rate kilogram in cubic meters, but the power is mean 3. Okay, well, what are the dimensions of the rho of density is the dimensions of mass divided by the dimensions of volume L to the power of 3, so that the dimensions are m point L to the power of min 3. Next, we want to derive a principal quantity from length and time. What can we get? The first is speed. As you already know, we can get from the length divided by time, so that the unit is the unit of length of the meter and the unit of time is seconds, so that ampere is obtained, or we can write ms to the power minus 1. The dimension of speed is the dimension of length divided by the dimension of time, L per t, or Lt to the power minus 1. This is the dimension of speed. In addition to speed, we can also obtain the acceleration of acceleration we can determine from the division of v against t. Speed divided by time, so that the unit of acceleration is the unit of speed, ms divided by the unit of time. The result is meters per second square, or we can write ms minus 2. Well, for the dimensions of acceleration are the dimensions of speed, Lt minus 1. This is what we get above. The result is Lt minus 2.
Now, we will discuss about significant figures. Do you know what is significant figures? Significant figures is a number obtained from measurement and provide information about the resolution of measuring instrument used. There are some rules of significant figures. The first one is all non-zero numbers are significant. For example, is 423.67 centimeter. And then a zero that lies between two non-zero numbers is significant. For example, is 400 to 23.67 centimeter. Rules of significant figures. That is, all zeros located in the last row of a number written behind the decimal point are significant figures. For example, is 2.0 and 2.00 and then 12.50. The rules of significant figures, that is, the zero of the decimal point, are not significant figure. For example, 0.3 and 0.003. The last rules of significant figures, that is a number in the tens of thousands, of hundreds, and so on, that have odd in the last row, are written in scientific notation. For example, is 100,000 is equal to 1 times 10 to the 5th power. And then we go to discuss about addition of significant figures. If the first number after the retained number is less than 5, then that number and the numbers behind it are omitted. For example, is 124.434587 bigger than 4 EP becomes 124.4. And if the first number after the written number is bigger than 5, then that number and the numbers behind it are removed and the last written number is increased by 1.
For example, there is 124.474587. We retain another 4 significant figures. Now, the first number after the retained number is 7. 7 is more than equal to 5. So, if we run it to 124.5, the last retained number increased by 1. That's for rounding significant figures. Okay, here is the closing video assignment of Group 5 with the material of quantities and units of measuring instruments and significant figures.
Wow, it was really exciting to learn about the magnitude of measuring units and significant figures. Not just formulas in the books, but really useful for everyday life. I hope this video makes you understand more and excited to learn physics. Don't forget that accuracy is very important in measurement. Like we really made this video. Trust exploration and smoke your abilities, who knows, to be a great scientist in the future. Thank you for watching and see you soon.